Example 3, find the common ratio and the first term in each sequence, I guess in each of the sequences described. So we know that the fourth term is -4 and the seventh term, okay, whenever I see this in these big gaps, I like to kind of just draw it. So I've got that, I've got the first term, second, third, now the fourth term is -4, and then the fifth, the sixth, and then the seventh is -32. So there's no way I take T1, nope, don't know it. My R from one to the next, don't know it. How many terms there are? Well, I guess there's 7, so my N could be 7. So I'm missing a lot of information. Now, when it comes to these ones that have these gaps in it, you know that you go from -4 to here, you're timesing by some sort of R. And you know that you're going to go from here to here, you're also going to be timesing by an R. And then from here to here, you'll also be timesing by an R. So you should know that if you are at -4, and then you times by R, times by R, times by R, you're going to get -32. So really, you have -4 R cubed, R times R times R is R cubed, equals -32. Don't know why I wrote an 8. Now I can solve for R. I can divide both sides by -4. Divide these -4 over there. So now I've got an R cubed -32 over -4, which is 8. Maybe that's where I got the 8 from. And then I can cube root. The cube root will be on both sides. And that will cancel. So I just have R is equal to the cube root of 8. Now the cube root of 8 is just 2. So my R is equal to 2. Maybe I'll do that in red. So my R is equal to 2. Now, was I asked to find that? I don't remember. Find the common ratio and the first term. Well, I'm actually just going to go ahead and find all of the terms because I'm just timesing by 2. So -4 times 2 is -8. Times 2 again is -16. Now, if you're working backwards, you got to divide by R. If you're going this way, divide by R. So -4 divides, so just work backwards. -4 divided by 2 is -2. Divided by 2 is -1. Divided by 2 is -1/2. Right? So -2 divided by 2, well, that just reduces to -1. -1 divided by 2, okay, well, -1, well, that's just -1 over 2. So I found all of the terms. I mean, we were specifically asking for this one, but I decided to find all of them. So that's term 1, and then my R was 2. Okay. Now we have same sort of thing, but third and eighth term. So I don't know the first term. Let's move this over here. So I don't know the first term. I don't know the second. I do know the third. It's 81. Fourth, nope. Fifth, nope. Sixth, no. Seventh, no. 8, yes. -1 over 3. So the third, 4, 5, 6, 7, 8. Okay, so I know that I'm timesing by R to get to that one. And then timesing by R again. And then from here to here, timesing by R. Here to here, timesing by R. Here to here, timesing by R. So 81 times R, how many times? 5? Gets me -1 over 3. So I've got 81 R to the 5 is equal to -1 over 3. Now, one of the things that I don't like to do is when I'm solving here is dividing by 81. I don't like dividing by, have a fraction divided by a fraction. And so in the same way that I told you in the previous, one of the previous videos here, that you can, that dividing by 2 is the same thing as timesing by half. What I'll do here is I'm not going to divide by 81. I'm going to times it by 1 over 81. Either way, the 81's on the denominator. That way, that'll just cancel with that. but I'll do that to this side too. 1 over 81. So r to the 5 is equal, negative 1 times 1 is negative 1. And then 81 3 times. So that's 243. And then I need to do a fifth root onto both sides. Now, lucky for me, usually you can't square root a negative, but here it's a fifth root, which is an odd number. So you're allowed to, if your exponent is an odd number, you can have negatives. So I'm going to kind of bring this up here a little bit. So my r is equal to the fifth root of negative 1 and the fifth root of 243. I just separated those roots. Now the fifth root of negative 1 is just negative 1. But I need to do the fifth root of 243. Now we do this just like we've done all of the other ones whenever we're reducing things, and we can't just do it in our head, like the square root of 81, I know is just 9. But if you can't do that, you can split these up. Now I know that this is 81 times 3. I know that because I already did it here. 3 times 81 is what got me 243. This 81 can break up to a 9 times 9. I can bring down the 3. And these 9s can each be a 3 times 3. And bring down that 3. Okay, so because it's a fifth root, we're now looking for groups of 5. And like, yes, we do have 5 3s. So the 3s can come out, and the leftovers are nothing. So it's just a 3. So the fifth root of 243 is just 3. Just like over here when it was an 8, we could have made this 4 times 2, and 4 is 2 times 2 times the 2 down there. So you're getting groups of 3, and so there's a group of 3, which is just 2, and what's left over? Well, nothing, which is why our answer was simply just 2. And you should know what the cube root of 8 is. It is just 2. And the cube root of 243 happens to just be 3, but that is on the bottom. The cube root of negative 1 is still negative 1. So this is what my r is. My r is negative a third. So if you're timesing by a third, you can, this right here, this is timesing by a third. Negative, timesing by a third. Now, you can think of it this way, or you can think of it as dividing by 3, which I think is a little bit easier. So, or you can think of it as dividing by 3. So 81 divided by 3 is 27. 27 divided by 3 is 9. Oh, it's negative 3. So 81 divided by negative 3 is negative 27. Negative 27 divided by negative 3 is in positive 9. 9 divided by negative 3 is negative 3. Negative 3 divided by negative 3 is positive 1. And 1 divided by negative 3 is just that, 1 over 3, but negative. Now working backwards here, right, because we were just going divided by 3, divided by 3, divided by 3, 3, 3, that sort of thing. Now to work backwards, then just do the opposite, times by 3, and then times by 3. So 81 times 3, 8 times 3 is 240, and then a 3, and 24, 24, and 24, that's 75, 72, and 3, 3, 3 is 9, so 729. And so that is my first term. So I'll zoom out here, and you can take a look at this. The last thing to keep in mind here is, and you're going to find this in the worksheets, whenever you square root something, so say you have r is equal to 16, r squared, and you have to square root it, or a fourth root, anything with an even number. And this is why this is in the notes. But you can square root it, and r is equal to not just 4, but plus or minus 4. And so when you have to work backwards, you have to do two cases. You have to do a case where there's a 4 and a case when there's a negative 4. And it doesn't really make a difference. It just means that all of these things will be plus and minus, plus and minus, plus and minus. So that's all you're really changing. But keep that in mind, and that's why it's in the worksheets for you to practice. And so I would highly suggest that you try those. But otherwise, they're done in exactly the same way. So we have some more questions to do. So I'll stop it here, and we can do the other one after this.